In this video lecture, we are going to see the evolution of DBMS, how DBMS was evolved over the years. In the 1960s, first people used flat file based systems. In the 1970s, people used network and hierarchical database management systems. In 1980s, they used RDBMS, Relational Database Management Systems. In 1990s, object-oriented database management systems and object-relational database management systems came into existence. In 2000 plus, web-based database management systems came. So we are going to look at all these DBMSs, and at the same time we see the advantages and the drawbacks of each and every DBMS.
We see the evolution of database management systems, how database management systems has evolved over the years. This is the chronological order of the evolution of DBMS. The first one is flat files. Long back, 1960s to 1980s, people used these flat files to store their data. And then hierarchical database management systems. They came in 1970s and they existed up to 1990s. So nowadays we are not using these hierarchical DBMSs. Then network database management systems came in 1970s. Of course, they also existed up to the 1990s. Then came the RDBMS, which really changed the database management systems idea of the people. Relational DBMS. So from 1980s to present, still we are using RDBMS in some companies. And then came OODBMS, object-oriented DBMS, and ORDBMS, object-relational database management systems. Then came recently data warehousing, and we are now using web-enabled database management systems. Now we see one by one. The first one is flat file based system. So now, what is a flat file? A flat file is a simple file. So daily we work with different types of files, right? So it is a simple file where we store the entire data of a company. For example, if you want to store the details of a student, you can create a file called student.dat data file, and then you can straightway typing the names of the students, numbers, and all the details of students. Now this file based system, it was the predecessor to the database management system. So first came the file based system. Then flat files store the information in a single file. Just now I told you we can create a file like this. For example, here I'm writing student.dat. It's a simple data file where you can store all the details of student. Every line is a record. For example, then we'll see the example in the next slide. Every line is called a record. A record consists of number of fields which are separated by either commas or white spaces or tabs, or we can use any other characters. Now this is the example of a flat file. Have you observed these are called records, and very similarly this record contains number of fields. This is field 1, field 2, field 3, and field 4. So in this way, if you store the details of a company in a single file, it is called a flat file. Now we see the advantages and disadvantages of using the flat files. Now, flat files are best suited for small databases where if you have a company with 5 to 10 employees or a college with 5 to 10 students, then it is very good to store the details in a flat file. But nowadays, whenever we store the details of either employees or the students, a number of employees, number of students, hundreds of employee details we store, right? So in that case, flat files are no more useful. They are not useful. Then the second point, it is very easy to understand and implement. Just now we saw one example, right? Very easy to type all the names of students in a single file. And also, no need to have good software skills or hardware skills to deal with the flat files. These are the advantages of flat files. Now, the disadvantages. The first disadvantage, a flat file may contain fields which duplicate the data. Just now we saw that every flat file has number of records. Each record has number of fields. Sometimes the fields data may be same, or 2 3 fields may have the same data. When we delete a record, all the relevant information in different fields has to be deleted manually. A record means it is a row, right? If you want to delete a particular row, what you need to do is you need to delete each and every field manually. Then it also wastes the computer space. Sometimes the fields are duplicated, so it wastes our computer space. Then if it is a large database, then information retrieving means getting the data from the flat file is very difficult when the data becomes very large. These are the disadvantages of file based system. Then the hierarchical DBMS. Now we see hierarchical DBMS. Hierarchical DBMS or hierarchical databases, they contain data in a hierarchically arranged order. So this one, hierarchically arranged data means in the top we have a particular data, and then we have something like this, right? Okay, then it is a hierarchy. It is called a hierarchy, right? Now hierarchical databases, they will be like this. It can be imagined as a family tree where there is a parent and a child relationship. So one parent and two children, one parent, two children. Here in hierarchical DBMS, the relationship will be like this. Now each parent can have many children, right? Each parent, this is parent, it can have many children, but one child can have only one parent. Here we cannot draw one more box here, one more rectangle here, and we cannot connect this child with some other parent, right? So here the important point in hierarchical databases is hierarchical databases, they support one to many relationship. Here one, and here many, one to many relationship. In a hierarchical database, rows of a table represent the records and columns represent the attributes. So rows of a table, if you can think of a big table, and if it has number of rows like this, then each row represent a record, and each column like this, each column, they represent different types of attributes. Now this is the example of hierarchical DBMS. Here you can see parent, child, one parent, multiple children, one to many relationship. So employee, an employee can be a permanent employee or a contract based employee, or internship. If somebody is doing some internship in a company, they will be called as intern employees. Now contract employees, again, sometimes manager or engineer. So anyway, this is a hierarchical DBMS example where we can see hierarchy like this: parent children relationship, one to many relationships. What are the advantages of hierarchical DBMSs? Hierarchical DBMS is retrieving the information. Retrieving means getting the information from the database takes less time due to the predefined paths. Yes, there is a path, right? Parent and children. So here, what you can say is the performance is increased performance. Yes, then the relationship among different entities are easy to understand. If there is a parent children relationship, and it is very easy to understand the relationship. These are the advantages of hierarchical databases. The disadvantages of hierarchical DBMSs. Here, there is no flexibility because only one to many relationships are possible here, and whereas many to many relationships are not possible. Many to many relationships are not possible in hierarchical DBMS. Then maintenance of data is inefficient in a hierarchical model. When if there is a change in the relationships, then we need to reorganize the data manually. For example, if we have a parent-children relationship, and sometimes if you want to modify the relationship parent-child to relationship, then what we need to do is we need to change the entire structure of the database. So it becomes very difficult here in this. If you want to change the database structure, it is not easy. Then this model is inefficient for non-hierarchical accesses. So sometimes some types of problems or some type of data may not be represented in a hierarchical manner. So in that case, it is very difficult to store the data. Next comes the network DBMS. This network DBMS model was first developed by Charles Buckman, and the network DBMS, it allows multiple parent and children relationships. The main difference between hierarchical DBMS and network DBMS is in hierarchical DBMS there are no many to many relationships, whereas in network DBMS we have many to many relationships. So this is the main difference between hierarchical and network database management systems. Network DBMSs are generally a graph structure. They have a graph structure. In a graph, we can have many to many relationships, right? We have nodes and edges in graphs. Similarly, here also we have number of nodes and edges. In a network DBMS, a relationship is referred to as a set. Each set comprises of two types of records, a owner record and a member record. Here we use these two words, owner and a member. Now this is the example for network DBMS, where here it is a store. Now in a store, we have customers, and in a store there may be some managers and there will be some salesmen, right? Then at the same time, customers can order the goods, or managers they can order the items, and at the same time, salesmen also they can order the items, some goods, and at the same time salesmen they can only sell the items. Customers and managers they don't sell the items. Salesmen they sell the items, and at the same time they can also buy the items. So here what we can see is a many to many relationship. Here we see customer and manager, many to many relationship. Now we see the advantages of network DBMS. And the greatest advantage is we can have many to many relationships, and this model ensures data integrity because the member can exist without an owner. User should make an owner entry and then the member records. Just now I told you that here owner record and a member record. First owner record should be there, then only we can have member records. We cannot have a member record without owner record. So data integrity means correctness of data. Here integrity means correctness of data. Then the network model also ensures the data independence because the application works independently of the data. Here there is another objective of database management system is data independence. The database should be independent of our application program. Here it supports data independence. Now, what are the disadvantages? What are the disadvantages of network DBMSs? Here, all the records are maintained using pointers and the whole database structure becomes very complex. Yes, in network database management systems, the database structure becomes very complex. And to insert, delete or update the data, it requires a number of pointer adjustments. We cannot easily modify the data, but it requires a lot of pointer adjustments. Then comes the relational database management system, which is very much useful and widely used DBMS. Now it is proposed by a person and his name is EF Cod, and it is the most famous data model. So, and it is used by many people. Widely used DBMS is RDBMS. Remember, still we are using RDBMS. So here data are structured into tables. Here it is important here. In RDBMS, data is structured into tables. We all know what a table means, right? A table has number of rows and columns, and here we use a particular jargon where we use record and tuple. Each row is called a record and each column, it's an attribute, right? It's an attribute. And record or tuple means it is a row. This is an example table where these are some registration numbers of employees and the name of an employee, then job, age and salary. Here what is it? It is a table, right? And we can give a name to this table, employee details. Yes, it is a table. Now in this table these are called, this is a row. This is a row. Here it is a row, right? Then these are all called columns, right? This is a column. So similarly these are all called columns and these are rows and columns. Remember, rows means records or tuples, column means attribute. Then what are the advantages of DBMS? Relational database management systems, they support set operations. In mathematics we study sets, right? So there we can use union, intersection, difference and Cartesian product. Here we can have two tables, and the first table and the second table, sorry, these two are two different tables, right? And what we can have is these two tables with these two tables we can work with the union, intersection, difference, and these two tables contains different types of data. Then they also support selection, projection, and relational join and division operations. We'll see later. We will be discussing about the RDBMS in a very detailed manner. So RDBMS uses a language which is very easy and human readable. Now we use here SQL structured query language. We have a DBMS lab also. There we will be studying about SQL, which is very easy to understand, and at the same time it is human readable. We can easily read and understand the SQL. Now, what are the disadvantages of DBMS, relational DBMS? Here, the relational DBMS RDBMS disadvantage is if the number of tables are very high. I mean, there are many tables in the database, then the response time will be very high. If the number of tables and the relationships between tables, just now I told you we can have tables like this. We can have number of tables in a database, then we will be having different relationships among these tables. If the number of tables are very large and the relationships are also very high, then it is very difficult to uh, get the response. Now, and at the same time, it is also costly. We need to buy a particular software. Now, then comes object relational and object oriented ORDBMS and OODBMS. These are called ORDBMS and OODBMS. These two DBMSs, there are certain differences between these two DBMSs, but we are not studying them in detail. I want to give you some of the points which are common to ORDBMS and OODBMS. Here, the data or information is presented in the form of objects. Yes, we know about objects, right? In object-oriented programming languages like C++ and Java, I studied object, which is a real-world entity. Object, it consists of data and operations, right? Object is equal to data plus some methods or operations. Then OODBMS and ORDBMS, they implement object-oriented concepts. We studied like objects, polymorphism, encapsulation, inheritance. These are all object-oriented concepts, right? Object-oriented programming language concepts. Then an object-oriented database stores complex data as compared to RDBMS. Yes, when we are dealing with objects, we have a lot of flexibility to work with polymorphism, inheritance, and all these things, which are not actually supported by RDBMS, simple RDBMS. But OODBMS and ORDBMS, they support the concepts of objects. And lastly, we see data warehousing and web-enabled databases. I'm just here giving the outlines, the definitions. Right? What is a data warehouse? Here, the data warehouse is an information system which stores historical data from multiple sources. Yeah, from multiple sources, it stores lots and lots of data, and which is used to report and analysis of data, which is done by the data warehousing. And finally, web-enabled databases. These web-enabled databases, they are designed to be managed and accessed through the internet. If there is these databases, web-enabled databases, can be accessed by the internet. But sometimes these RDBMSs, they are actually installed in a particular system, computer, and we can access through the computers which are connected to the server where RDBMS is installed. But here, the web-enabled database can be accessed by or through the internet. Okay, thank you.